Cool. So, sorry, I don't know whose project this is because I'm only looking at the GitHub, but we also saw a lot of customization with this project as well, both with the calendar and be able to select priority and customization of the actual list view.
Can you raise your hand with yours?
Nice. We saw similar results as well with this project. So whose project is this? Nice. So again, we saw, I believe, a fragment view that allows you to add a new task, customize priority, select new dates, so on and so forth. And the last one, where we saw the use of the navigation bar to be able to create your to-do, and again, customization with calendar and priority. So whose project is this? Nice. Cool. So by no means are we trying to reduce the quality or the work of everyone else's, but of course everyone did a great job with the pre-work, and that's why you guys were admitted to this class. So before we get started, we wanted to sort of describe the class structure. So as you guys know, this is an 8-week class. Lectures are not on Monday and Wednesday. They're actually on Tuesday and Thursday. We're going to be doing lectures on Tuesdays and labs on Thursdays. You guys will have weekly assignments that are due on Sunday at 11:59 p.m. So this gives you guys the entire weekend to work if you guys want to. And from weeks 4 to 8, you guys will have your own project, and then we will have a demo day in early April. Is that correct, Harley?
Yeah, last day is Thursday, April 6th. So on that day, your final sort of internal demo day presenting your project.
Right.
And then that's week 8. Week 9,
Yeah.
we'll do something that we will announce.
Yeah, and the week after, is a public demo day. Cool, so some class rules. You guys must come to every class, so thank you all for coming today. Try to come to class on time, because we want you to maximize your time here. Homework must be submitted at 11:59 p.m. You are allowed 124-hour extension. And the last and most important is that you must be honest. So we have pretty strict rules here. If you break any of the rules, you have the potential to be kicked out. This is not to threaten any of you guys or anything like that, but it's just something that we want to enforce. Cool, so how do you guys get help? So most of you guys are on the Facebook group, is that correct? We also have a Slack group. One of the TAs will actually create, I believe, individual channels for like lecture 1, lecture 2, or on a week-by-week basis so that we can post links and share and discuss. Make sure to ask us any questions. All of us are here to help. Make sure to ask your peers. You can email android@coderschool.vn anytime, and hopefully we'll respond pretty quickly. So some tips. Start your homework early. Breadth first search approach. So try to understand a lot before just trying to tackle it. Work together, share your discoveries, and definitely try to do the optional or bonus homeworks. We'll definitely highlight them on every single lecture. Cool. So welcome to Android. I love this costume, by the way.
I will wear it on demo day.
We'll wear it on demo day.
Yeah.
Cool. So actually, one of the things I want to do is jump in and sort of just talk about some screen archetypes and some common screens that you guys will see. So what I would love for you guys to do is actually talk about the functionality behind each one of these screens and see if you guys can sort of define what each one of these screens does. They're pretty simple, but if anyone wants to just jump in and shout them out. So for the first screen, it's a pretty common screen. What's the functionality behind it?
Authentication.
Authentication, yep. Login, yep. The second one? Registration, right. The third one?
Recovery password.
A third one? The Facebook one?
Yes, Bill.
List view.
Recycle.
Yeah, all of you guys use list view. Yeah, I mean, list views definitely make sense. Maybe like streaming is how we sort of see it, like a real time. What about the fourth one, the Airbnb one? Yeah. Yeah, like details, like just being able to see like most people have like on their stream or on their list view something very simplistic, and for the screen you present more details. What about the fifth? Posting, yep. So sixth? Seems similar, right? Yeah, it's like a gallery view or whatever. And then, of course, account settings and map view, right? So we can kind of throw them up. But these are like the most common screens that you see, not necessarily just on Android, but on a lot of apps, right? So one of the things that we want to focus on is functionality, and not just like, learning Android, but thinking about like user and user experience. So that's kind of why we throw these screens up. So yeah, we want to talk about like data-driven apps, and we want to talk about how this relates to some of these core concepts or core engineering concepts. So in our opinion, the 5 most important are views, events, navigation, data, and platform. So most of you guys in the pre-work have already worked with views. So this is like what you present to the user. Events, which are sort of things that happen within the app, such as if a login happens, you want certain things to happen. So we consider that events. Navigation, which is flowing from one view to the other. Data, which of course is like everything from networking, getting data through APIs, and of course we want to talk about platform, which is sort of the low-level stuff in Android, such as OS, hardware, and basically accessing any sensors on the phone. Cool. So we'll see a lot of, and before we dive into Android, we want to talk a lot about some higher level constructs. So how many of you have heard of like MVC, Model View Controller? Good. Okay, quite a few of you guys. So it's a higher level organization, but what the purpose of it is actually separation of concerns. So there's a clear reason why views, controllers, and data are separated. And what you'll see when we start talking about the details of Android is how they partition and how they separate each one of them, so that you don't have you have a clear interaction between the 3. And actually, let's skip straight into talking about app fundamentals. Cool. So one of the things that we want to distinguish is between a library and a framework. And I think this slide is a little bit too simplistic, where it says libraries are called by your code and framework calls your code. So can anyone sort of talk about why there's a difference between a library and framework, or what some of the differences are? Yes?
I think when we call it libraries, we expect it to return us something, so that we can continue to course we call this. And frameworks is when it will build your course, somehow build your course into the final product. These frameworks.
Yeah. Yeah, that's actually a really good explanation. So I tend to think of libraries as something very specific that solves a very common developer problem. So we can imagine like something like image caching. Instead of making a request every single time to go and pull an image through a network, you might want to save it locally on your phone. And so these are libraries that have a very specific purpose that you use to go and grab and get something back. A framework tends to be a little bit more general purpose. So we think about taking and general purpose in the sense that it gives you guys flexibility to do what you want, right? So if we define Android as a framework for building mobile applications, what the framework does is it basically assembles your app. it basically knows how to run your app, it knows how to start your app, and knows how to stop your app. And then it basically the code and the things that you implement, it will access them and run it for you, right? So the Android source, as you guys have already seen in your pre-work, has a very specific structure. So a framework, for the most part, defines a structure in order to read, so that they know how to go and access and get these access your source code and access the various components that you guys create. So for the Android source, there's of course the Java sources where you guys put the activities and any other Java implementations. There's a resource directory which contains layouts, drawables, and values. So the layout directory is for an XML defining your UI. A drawable is for storing your images, and you have your values, which defines colors, strings, and so on and so forth. And then there's another directory, a third directory called assets. And the assets directory is stored for miscellaneous files such as text and maybe even sound files. So can any of you guys tell me why Android might separate the resource files from the assets files? No? Any thoughts? Maybe this is too complicated to talk about for now, but we'll skip it and we'll come back to it.
Can you have variables in the resource files?
Right, exactly. So
It's like a constant, you retrieve them in assets, everything is just
Yeah.
static.
exactly. So if you think about Android as a platform, you're not supporting just your device that you have. You're supporting a lot of different devices, and they have to account for all these permutations. Permutations meaning like all these different types of phones. And so as a result, they have to have a very concrete file structure to access the various layouts and the various drawables or images for each screen size, each orientation, and so on and so forth, and basically like languages, right? So if you have someone who's on a phone whose setting is English or Vietnamese, you potentially want to have different settings for each one of them. Versus assets, which are like text files or music files, they will apply to all devices, right? Like you'll play the same music for every single device. Does that kind of make sense? Does that make sense? Cool. So the two most important files are the Android manifest and the Gradle file. So the manifest file contains application-wide settings. Most of you guys have worked with it in the pre-works. So if we actually go and take a look at a simple app. So this is an app that I just created, a new project file that I created. We take a look at the manifest. It's pretty simple, right? We have definition, a package definition, we have the application definition, we have things like defining like the various activities we have. But it actually, we actually have a lot more that goes in there. So it also defines things like permissions and supported devices. So one of the things I want to show you guys is an app that I wrote. It's a little bit more complicated. So you can see definitions for permissions. So I'm going to be using the internet, camera, audio, external storage, getting user accounts. I talk about the screen sizes that I want to support. So one of the things you'll realize is, certain countries might have smaller devices. For example, India, a lot of people use really small devices and you don't want to support them, so you can exclude them. And of course, a lot of activities and configurations that go inside of each one. Cool. So the second most important file is your Gradle file. So as we talked about, a framework what you're doing is you're assembling a project, and then you're basically taking the code that you guys write and assembling a final file. So Gradle is a general Java build system, but for Android, they actually included it as part of Android Studio with some special configurations. So this takes your existing code, this structure, and it compacts it into a final file called an APK. And this is what gets installed on your devices. So if we actually take a look at a Gradle file, it's quite simple, right? It just says Android. But this is actually a function that has a lot of different steps. So we specify things like your min target version or your version code, but it actually does a lot behind the scenes where it takes that entire structure, compacts it, and generates a final file. So that's something that's really nice about Android and Android Studio, is that it gives it to you sort of pre-bundled. So do you guys have any questions at this point?
There are 2 build.gradle in the project.
Yeah. Yep. So, sorry, not this one. Yep. So basically, you can have a lot of different configurations and stuff. So sometimes it's almost like a hierarchy, right? So you have this app Gradle that is used specifically for building this app, but you can also have a lot of different other configurations. I have never had to modify this one before, but this is the primary one that you have to worry about, which is the one that includes your Android settings and your dependencies. Cool. All right, guys. So what we're going to do is jump in and just make some configuration changes. So if I actually run this app, sorry guys, it's going to go some time. We're going to see a few things, right? We're going to see the app name is called Demo App. We're going to see a launcher, also called Demo App. And then if we go into settings and we look at apps, we will see under Demo App the version 1.0. So what we're going to do is we're going to change the name of the app, and we're going to change the version of the app. So let's start by changing the name. So the name is specified in your Android manifest. Within the Android manifest, you have this label, right, that references that string app name. So if you can command click on it, it will reference this strings file with the name app name. And so let's change it to Android Coder School 2017. Let's go ahead and run that. So this string is actually used in 2 places. It is used both in the Android manifest, and I believe it's used somewhere else. I believe it's used in the definition of the main activity somewhere. But we can worry about that later. But if we go back to the simulator, we can see that the name has changed. You can see the launcher has changed. So exactly what we want. The next thing we're going to do is change the version. So that is defined in your Gradle file. And so let's change the version to 2, version name to 2.1. Let's run that. So most people don't change their names after the first time. Hopefully that's the case. Okay, so and let's take a look at that, right? So let's go to settings, apps, and then we can look at, I think this is it. Yep, version 2.1. Okay, so actually, for most of you who have any of you guys released an Android app onto the Play Store before? One? Anyone else? So if you don't change your version name, they won't allow you to upload. They'll actually prevent you and stop you and say, oh, there's a conflict. So this is actually what a lot of people forget to change right before release. And then you have to do another check-in and all that stuff, right? So, all right, let's go back to the slides. Cool, so that was pretty simple, right? Any questions? All right, none? All right. So most of you in your pre-work have worked with the activity. As you guys know, an activity in Android is meant for to display a full screen. So every application basically has one active activity at any given time. And it's basically composed of a lot of different flows between activities. So in your pre-works, you guys navigated from one activity to the other, sometimes to get a result. Within activity, we usually see two parts. One is a Java file, and the other is an XML file. So the XML specifies your layout, and of course the Java file specifies like dynamic things, things that you want to manipulate in code. These two are not directly dependent on each other, but so if we go to an example, go back to the code. We have this main activity, and we have the layout, right? So we already see that there's a text view in there. And so for this example, what we're going to do is go in and just change the text. Pretty simple. Cool, it says hello world, right? So I don't know, what do we want to change this to? Any suggestions?
Valentine's.
Valentine's Day? Happy Valentine's Day? Alright. Vampires, alright. Let's run. Cool. Happy Valentine's Day. Flowers. What was that?
You can get email to pick up it. Pick up email.
Pick up flowers. Sweet. So what's sort of happening there, right? Is that it's basically just taking this layout and like showing it on screen, right? And so we'll talk about constraint layout a little bit later, but what we have is a text view that is centered within the entire activity. And what we just did was we changed the name. So another important thing to talk about is the resource file or the resource directories, right? We sort of described that in the project settings. So they define a lot of different things, right? They define strings, images, colors, what else? Styles, yes, styles as well. But behind the scenes, what's happening is that the Android framework is basically taking those things and remapping them into this file called R. So you can refer to each one of these files by calling r.string, r.layout, r.drawable, and then the name that you define in your XML. So this is actually really important when we talk about the framework because there's a lot of optimizations and a lot of performance that goes into this. So Google spends a lot of time optimizing R, but we refer to it only simply as a one-line sort of thing in the app. So if we actually want to change, one of the things that we did was that we referenced this text, we kind of hard coded it, right? That's not what we want, right? That's actually like because we want to support a lot of different languages and we want configurability. Hard coding is not like a good thing. So we tend to be able to refer to a string like this, and if we actually go into strings and add string name Valentine, and then we go back to the main activity, so it should pop up, right? And then if we run, we should get the same result. Cool. So any questions at this point? No? Okay. So there's just a lot of, so basically R refers to each one of these directories. So we see a layout directory, a drawable directory, colors, dimensions, strings, and as you mentioned, styles. And so we sort of described why that's the case, right? Basically for Android, you're working with a lot of different device types and situations. So how many of you guys have Android phones? Unfortunately, I'm no longer an Android user, but how many of you have like a big iPhone or Android phone? Big? You want to show it? Show it off? No? How big is it?
Oh no, it's not big.
It's not big?
But I have one.
Yeah. Do any of you guys have tablets, Android tablets?
Like this.
Wow, that's pretty big fun. That's really big fun. So as I mentioned, like this framework is, like Android is specifically designed so that you have all these like producers of phones. They can manufacture whatever they want, and yet you can write apps that work with all of them. Cool, and we just actually went through the step of adding the hello world to the layout. So do most of you guys know like the activity life cycle and what an activity life cycle is? What?
Not really.
Not really. Okay. Does anyone else might know? Activity life cycle?
Life cycle means when it's born and when it dies.
Right, right. So as we talked about, Android is a framework, and so they provide various hooks. So again, a framework is used to assemble, start, and stop your app, right? And so the three most important in the activity cycles, there's basically a lot of different touch points or a lot of different callbacks that you can implement. There is a reference on the Android guide, which has a user flow. Actually, let's see if we can bring it up. For Android. Oops, not this one. Sweet. So we can see when the activity is launched, there's on create, on start, on resume, and then your activity is running, and then an on pause when your activity moves from the foreground to the background, on stop, and then on restart. But the three most important is on create, which is called as soon as the activity is created, on pause right when you're leaving, when your app goes to the background, and of course on resume, basically when your activity comes back to the foreground. And so we can kind of go through an example of implementing these. So what we're going to do is add a log.d call. So does everyone know what log.d does? No? Have any of you guys used like Logcat? Okay, perfect. So
What's the difference between log.d and system.out.py?
so system.out is actually defined like for Java. It's used for like console, but log.d is specific for Android. So Android has a completely separate logger, and you can print everything from debug information to warnings to information. So it's almost like a nice looking structured log that people can refer to and parse. And I'll actually go through an example of that right now.
There are many different types of log. The log in, log in.
Exactly. So let's go ahead and implement that.
So how is different between log and log in?
So log D is log debug, log E is log error. And so you can actually see, actually I would recommend that each one of you guys go and play around with it and see what that looks like. But basically, in your Android monitor, this is Logcat, and you can see like the output of your simulator or the output of your device as you guys are running the app. So let's go ahead and override some of these functions, right? So let's see, log D, activity has been created. Sorry. So if you guys want to override a function, you guys can simply go to code override or Control O, and then you can say, let's say you want on pause, and then on resume. Oops. Actually, let's do on start. Okay, cool. Start. So we will put breakpoints for each one of these. Actually, let's do. Let's do that for now. Cool. So if we run the app. Whoops. Yeah. Sorry. Let's debug. All right. We can see each one of these being called. So the activity has just been created. So if we go to Logcat,
Debug.
yep, and we basically step over this, you can see that the activity has been created. If we resume, we should see the on start now. So let's step over that. And we'll see that in the log. And then we can resume the app. Right? So the next thing we want to see is the on pause being called. And if we actually go to the simulator and basically click home and take this to the background, you see that the on pause is now being called. Cool. And you should see that activity has been paused. Any questions?
What happens when we train from the first activity to the next activity?
Mm-hmm.
Is the previous one out on the train?
It is paused. It is paused because, well, it depends on what activity you're navigating to. If you're navigating to another app, the OS will control that, right? But if you're navigating within the same app, it will be set to on pause until it comes back, and then it will call on resume. So yeah, it depends on what you're calling to, because again, these activities are very loosely tied, but the operating system, the Android framework and platform will know and call accordingly based off of the system. So sometimes they might even kill it because they're out of memory, right? So depending on how intensive your activity is or how much stuff it's doing, you might have to implement different parts of the life cycle accordingly. But for the most part, if you're just displaying something to the user, you don't necessarily mind if it gets killed. But you can imagine how that might change depending on what you're trying to do.
Also, may rotate the screen, right?
Yeah, that's correct. That is correct. Yeah. So you can configure the app to also not kill the activity on screen rotation, but some people, because they force the app just to be a specific dimension. But yes, every single time someone changes orientation, like you should see the activity get restarted. Cool. So how many of you guys played? Do you have a question? Okay. So how many of you guys played with unit sizes? Yeah. No? Okay. So as we mentioned, in Android, you're dealing with a lot of different types and situations in terms of devices. So the original phone, every pixel was 1 pixel, right? And then now you have a lot of phones where it's like 3:1 or 2:1 ratio. And so really, when you specify dimensions, you want to specify either as density independent or scale independent. And the rule of thumb that we are trying to enforce is that use SP for text size and DP for everything else. And so SP actually takes into account accessibility settings. So let's say like I am someone who has a hard time reading. I set my Android device to have bigger resolution or bigger text. It will scale according to that. So we can actually do that really quickly. So if we go to the text view and say, and just take this text size, say 50 SP, and run. So you see big text. If we go to settings and we change accessibility,
Font size.
Font size, set it to largest, let's change to smallest, and then we rerun the app. We see that it got smaller, right? So SP takes into account accessibility settings. Cool, so just a quick wrap up of the fundamentals. We went through everything from the Android project structure, talking about the Android manifest, the Gradle, how activities work, resources, activity lifecycle, and also like unit sizes. So do any of you have any questions at this point?
I see in the reverse symbol, I see it uses the combat activity, not the activity. You can explain the difference in the combat activity and the activity.
Oh yes, yes. So you were talking about this, right? Yeah, so one of the biggest problems with Android is that you have to support a lot of different like Android versions. So Google releases a library for compatibility reasons, which allows certain things like activities to work on older Android frameworks. So this part gets really confusing, and so I don't want to dive into it too much since we're just talking about the fundamentals. But basically, depending on what versions you want to support or Android versions you want to support, you should implement or extend app compatibility activity versus activities. Does that kind of make sense? So depending on like how far back you want to go. So actually, a lot of time is spent like testing. Because sometimes things don't work across Android versions.
So for this class, I can just use activity all the time.
You can, but you should set your Gradle settings according, right? Because you have a min SDK version. But if it depends on your simulator, right? If the simulator is set on the most recent version, I don't think you have to worry about it. But you can imagine if you change the simulator that is on a much older version, you should expect some sort of crashes. Any other questions?
I'm sorry, but when I missed the build up was the project demo, I don't know how to what's different for the two.
Yeah.
What's
So
different?
so they sort of do reference each other. Again, for most of the Gradle stuff, I don't actually, outside of you leveraging the Android function itself, I don't actually make a reference between those two. But most of it is just done here. So the truth is actually not quite sure the distinguishment between this one versus this one, but they do reference each other. And so I will actually get back to you on that. Any other questions?
Take a break.
Take a break? 5 minutes?
Before
Get a drink? Cool. All right.
The air conditioner is so annoying.
It's off.
It's annoying.